The next type of reaction is double replacement. So this is an exchange of ions between two compounds. Now in this case, you can either switch the two cations or you can switch the two anions. It does not matter which ones you switch. Just don't switch both or you're going to end up with the same thing. So in this example here, AX plus BY, the anions were switched. So it ended up being AY plus BX. So that's what's going to happen. Now, for this part, we're just going to assume that the double replacement reaction happens. They don't always happen, and we're going to talk more about that when we get to net ionic reactions. But for now, any reaction I give you, just assume it's going to happen. Later on, we'll talk about what it means if there's kind of a no reaction for a double replacement reaction. So here are some examples. So we have calcium hydroxide plus 2HCl yields CaCl2 plus 2H2O. So here, if it doesn't kind of seem obvious what happened, I'm just going to rewrite it out. You don't have to worry about the AQ or the liquid or anything. We'll talk about that later. So here, what happened was I just wrote the water as HOH. You had the chlorine and the OH switch places. So then the chlorine was now combined with the calcium, hydroxide was combined with H, but HOH is really just H2O. So if you leave it as HOH, it's okay, but you should probably rewrite it as H2O. In the next example, we have 2 sodium hydroxide plus copper 2 chloride yields 2 sodium chloride plus copper 2 hydroxide. So again, in this case, the two anions switch places. So now chlorine combined with the Na, hydroxide combined with the copper. If you have a transition metal, its charge is not going to change from reactants to products. It will stay the same. So the copper on the reactant side was a 2+. It's still a 2+ on the product side. That does not change. And just to start getting noted, to get used to this, the solid produced in the second reaction is called the precipitate. So anytime you have a solid produced in a chemical reaction, we call that a precipitate. And in the next topic, we're going to talk about how do you know if something's a precipitate or not. All right, so we're going to practice predicting the products. I'm going to switch the cations because I think that's a little easier. But if you want to switch the anions, it's fine. You're going to come up with the same thing. So lithium iodide plus silver nitrate. Don't worry about the AQs. So I'm going to change lithium and silver. Now, again, be aware, there's no activity series or anything. We're just going to automatically assume they switch. So now Ag will be paired with iodine plus lithium is now paired with nitrate. Now check your charges. Silver we know is always a 1+, iodine's a 1-, so AgI is correct. Lithium's a 1+, nitrate's a 1-, LiNO3 is correct. Since these all are 1, this is balanced. All right, BaCl2 plus K2CO3. So again, I'm going to switch the first two cations. So now my potassium is going to bond with chlorine, and then my barium is going to combine with carbonate. Check your charges. Potassium is a 1+, Cl is a 1-. We don't need any subscripts. Ba is a 2+, carbonate is a 2-. Don't need any subscripts. Okay, let's balance this reaction. So I have 1 Ba, that's good. 2 Cl. Okay, I got to make this a 2 here. Now the Cl's are balanced. Potassium, I have 2. Well, I just made it balanced with a 2. 1 CO3, 1 CO3. This is now a balanced equation. All right, if I were you, I would pause the video, try examples 3 and 4, and then check them with my answers. All right, so here we have aluminum nitrate is reacting with sulfuric acid. So I'm going to switch aluminum and hydrogen. So HNO3 plus AlSO4. Hydrogen's a 1 plus, nitrate's a 1 minus, so we're good. Al is a 3 plus, sulfate is a 2 minus, so we got to cross down those charges. Then we would have to balance. 1 aluminum, 2 aluminum, so I need a 2 here. That makes 6 nitrate. I only have 1 nitrate, so let's make that a 6. Here I have 2 hydrogen, I have 6, so let's make that 3. And then 3 sulfate, 3 sulfate. That is balanced. Lithium chromate plus barium chloride. First thing you got to do, well, is convert words to formulas. Lithium's a 1 plus, chromate is a 2 minus, barium's a 2 plus, chloride would be a 1 minus. So we have Li2 CrO4 plus BaCl2. So I'm going to switch the barium and the lithium. So barium chromate, and I already wrote my charges before. I know these are a +2 and a -2. Plus LiCl, which are +1 and -1. All right, so last thing I have to do is just check that this is balanced. 2 Li, make this 2 Li. I have 1 chromate, that's good. I have 1 barium, and then 2 chlorines, and I put that 2 already, so that's 2 Cls. So that is now balanced. So for double replacement reactions, all you're doing is either switch the cations or switch the anions. Make sure you recross the charges on the product side. And this is just a summary of the 5 general types of reactions. So for synthesis, it's going to be A plus B gives you AB. That's kind of the general form. Combustion, some substance plus O2 will normally give you CO2 and water. Decomposition, breaking down. So AB yields A plus B. And then single replacement would be an element and a compound. Makes an element and a compound and they switch spots. Double replacement, 2 compounds make 2 compounds and your ions switch. Now here's kind of another chart. How are you going to recognize, like if you have to predict products and everything's mixed up, how are you going to know what's a synthesis, what's a combustion, on and on. So a synthesis reaction will always start with 2 elements. You're going to make 1 product. So you're going to make a product from those 2 elements. Decomposition, you're going to start with 1 product, and then it's going to break down to 2 elements. Single replacement, you're going to start with 1 element plus 1 compound. Now, you have 2 options here. You might end up with 1 element and 1 compound, or you might get an NR, no reaction. Remember, for the single replacement, you need to use your activity series. Double replacement, you're going to start with 2 compounds, and you're going to end with 2 compounds. For combustion, you're going to have, really it's just the elements C, H, and O, but you're going to have some compound X plus O2, and that's usually going to give you CO2 and water. That's kind of how to tell your reactants and products for each type of reaction.